Alright, in these examples, and you can see this top one here, we're going to expand each of these, except this one, which is going to be too long to expand because we've got 50 and 30. In fact, this one will be a little bit too long as well. But we can see, hopefully, that as we find the denominators in exponential form, we can also write them using negatives. And it should help us to realize what a negative exponent means. Alright, so we can see here that I've expanded this expression, and we can get rid of these 4a's, which would give us 1 over a cubed. Now we've already gone over the quotient rule, so what we can do then is, since we have the same base a, we can take the power of 4 minus that 7 there, and that would give us then a to the power of negative 3. Well, notice we've just done the same thing, just using two different methods. This one expands the bases, and this one just simplifies it by using the quotient rule. Well, they're the same thing, as it turns out, and this indicates and helps us to realize what the negative exponents mean, which we can write in right here, right? 1 over a to the third is the same as a to the power of negative 3. And of course it would work the same way on the second one. So instead of expanding this second example here, I'll go ahead and use the quotient rule first. So I've got a, so I've got those same bases. We've got cubed, and then minus the denominator exponent of a, which is 6. And then we have the b's as well, and that would give us a 6 minus 10 using the quotient rule, which would then give us a to the power of negative 3 and b to the power of negative 4. Now if we expanded these other ones here, we'd still have a 1 in the numerator, but we'd have 3 a's in the denominator, and then would have also another 4 b's in the denominator, okay? So notice these are the same thing once again, where we have 1 over a cubed times b to the fourth here in the denominator is the same as a to the power of negative 3 times b to the power of negative 4. So go ahead and take a moment and try this third example here. It's too long to expand. So go and see if you can use the quotient rule and see if you can find the equivalent expression not using the quotient rule. And there you go. This would be the answer to the fourth part there. So whenever you see a negative power of some base, like you see here, it really just means that you're going to take a and you're going to invert it. So you'd have a to the power of n, but when you do that, it makes the n a positive like this. And you're going to see examples like this on your homework assignments, where it's going to give you an expression with the negative exponents, and it's just going to ask you to rewrite the expression, but without any negative exponents like this one. Now, I've heard this talked about by some other teachers, and this is just another way to think about it, is you can divide anything by 1. It's just the division property of, the identitive property of division. And some people would say, well, if we made this a go to the denominator, it would cross this line. And nifty enough, it just rhymes, so you would change that sign. So if it crosses the line, you change the sign, which is why that n is a positive right there. I don't know if that helps, but it's just another way to think about it. And I hope it does help anyways, and I hope you find this video helpful. So thanks for watching, you guys.